Very good evening, everyone. How are you all, guys? Yes, how about your studies? अच्छी चल रही है? Nice. Okay. Tell me, you all guys, which subject you have? Out of if you talk about physical, organic, or inorganic, which subject you find more difficult? Okay. अभी पढ़ा ही नहीं है. कुछ लोग कह रहे हैं, मैम, we have not yet started any studies. So you must be in class 11 now. कुछ तो पढ़ा होगा. जो पढ़ा है वो अच्छा लग रहा है. चलो ठीक है. Thank you. Welcome to you, Beta, for that. Yes. So, how are you all, guys? Come on, share the class. Today we are going to have a lot of studies. So, just share to all your friends. Faster. We are going to have a just what we are going to study boron and carbon. Till now we have done NCERT, isn't it? But there are still many things which are important if you talk about NEET. So yes, we are going to do that as well as NCERT plus, of course, things which we have not covered so far under NCERT. We are going to cover that, isn't it? So shall we start? That's nice. फटाफट से शेयर करो सबको. Okay. So once again, a wonderful evening to you all, guys. Myself Sharada Alok. I've been teaching chemistry at Resonance from past 10 years, guys. Now let me tell you what is there on the screen. Let me tell you about it. Yes, this is plus subscription. How can you get that? How you can get connected to us? Let me tell you, guys. First of all, just go to Play Store, download the Unacademy Learning app. I'm repeating, download the Unacademy Learning app. See, there you'll be finding one more app related to Unacademy, and there are many students who just get confused out of that. I tell you, Unacademy Learning app is for you, but the other one for which the students are getting confused is for educators. That is Unacademy Educator app. Remember, that is Unacademy Educator app, and this one is Unacademy Learning app, guys. So this is for you all, guys. So you have to just download this one. Is that clear? And yes, there after downloading this app, if you all guys want to join for NEET, just click on to NEET UG option, not PG. Yes, that also we'll be doing, but after getting into top medical colleges of the country, isn't it? So nice, beta. Yeah, बिल्कुल होगा, बिल्कुल होगा. Think for the best. Yes, होगा. So guys, after that, just click on to the subscription option. And before I explain you about the subscription, let me tell you the benefit of joining to us, benefit of taking this plus subscription. First of all, here you get daily live classes. Let me repeat, here you get daily live classes which are going to be taught to you by the top educators across the nation. I'm repeating, you are going to be taught by the top educators across the nation, guys. Is that clear? Now they will be teaching you particular topic, and not only that, you can ask all your doubts there itself in the very live classes. And yes, there will be poll as well. What is that? You are supposed to answer particular question being raised by the educator related to the topic being taught in the live class. And yes, by participating in that, you become very confident about the particular topic as well. Apart from that, here you are going to have live test and quizzes. Let me tell you about the benefits of them. See, we are going to have regular these live tests and quizzes on a regular basis. If you participate them and do well, you are going to find it out that after every live test your performance is evaluating. In fact, your performance is enhancing gradually. Suppose today, if you are if you are getting 150 rank or something like that, very soon, like it will happen gradually after a week or so, your rank is going to improve. And yes, it all depends on the type effort, amount of hard work, and yes, direction to which you are actually putting it into that, how fast your growth is there, isn't it? Then second one is, guys, quizzes. We are going to have regular quizzes. In that, what is going to happen? Apart from your academic evaluation, I'm repeating, apart from your academic evaluation, if you become the winner of the quiz, you know what happens? You're going to get a referral point out of which you can buy all the courses, like any of the courses of your choice, running at an academy platform. So this is the main actually important features of this quiz. Apart from that, here you are going to get structured course which is precisely designed by the top educators, guys. And yes, it is you can see this in a way as if like nothing irrelevant will be taught to you. Suppose you all guys are preparing for NEET, so your top educator has designed the syllabus in such a way that you'll be taught everything related to your target only. Nothing irrelevant will be taught to you. And apart from that, once again, needless to say, that just take one subscription, one plus subscription, and you get all of them, isn't it? This is something new we have recently been launched by Unacademy. Let me tell you, this is iconic subscription. Here you get personal coaches. Yes, guys, here you get personal coaches who are going to give you one-to-one guidance. Okay, and yes, apart from that, you'll be given a preparation strategy. Let me tell you, you'll be getting a proper preparation strategy that is definitely going to enhance your academic, uh, what to say, outcome. That will definitely going to improve. Suppose say you are putting whatever hard work you are putting now, and suppose you get a result x time after following this preparation strategy and all, that result has to enhance many times of that x. Trust me, that happens because you are going to follow a proper methodology, and definitely that is going to enhance your performance. Apart from that, this is test analysis, which is actually a proper in-depth test analysis you get out of it. Out of you suppose you give a test, so after the test, these personal coaches will go through your result. They will actually analyze how the way you have performed, or there are so many things. I just want to tell you that the meaning of in-depth analysis is what actually we mean by this in-depth analysis is, suppose you have been taught a particular topic, you might be doing in some topic very good, but like there are so many more topics which you might not have even given a thought. Even given, there are so many topics which we think padne ki kya zarurat hai, let us just leave it. But at the same time, those chapters are very dangerous if you leave them, because they are extremely scoring. So these things, these type of guidance will be given. Are you getting my point? And apart from that, will be shared a proper time management. And yes, you'll be given a proper exam approach. You'll be taught for apart from this regular topic, you'll be taught for following a proper approach towards the exam, because that is equally important, guys, in order to ensure your every success in the exam. And yes, guys, you'll be having a proper study planner that is, of course, going to ace your preparation with a proper customized study plan. And yes, you after that, you'll be having a bi-weekly reviews as well, which is definitely going to highlight your progress. Definitely, it is definitely going to highlight your progress, guys. So, needless to say, once again, that all these benefits after iconic subscription, you are definitely and surely going to get. Yes, guys, this is actually, you can see on the screen that this is actually the difference between plus subscription and iconic one. See, whatever you are supposed to get under plus subscription, the same thing you are going to get under iconic one. But of course, these are the additional features which is being added to that, of course. Now, how to take, like, how much you have to pay if you just want to go for iconic subscription? For 1 year, you're supposed to pay 45,000, which is going to cost you only 3,750 rupees per month. And guys, if you go for 2 year subscription, this is the amount. You're supposed to pay 61,000, which cost you around 2,542 rupees only. Yes, it is extremely economical yet affordable, guys. And don't forget to refer this referral code of mine. It's very very easy to recall, remember. SA10, I'm repeating, this is very very easy to remember. SA or 10 ho gaya. Now guys, this is for the plus subscription. You can see right from 1 month to 2 year subscription are there on your screen. If you just want to go for either 1 month 3 month subscription, see, these are the amount. But I would be suggesting you that you should think only for these subscription only when you are going for a crash preparation, and there is no point in doing that at least now, because almost 10 months are left for the exam, isn't it? So you should go for 12 month subscription, that is for an year, just by paying 27,000. That is going to cost you only 2,250 rupees per month. And if you're a student of class 11, I would recommend you that you must go for 2 year subscription by paying 32,400. That, yes, that very, difficult to believe, but yes, it is going to cost you only 1,350 rupees per month, guys. And yes, don't forget to refer this referral code of mine, which is really, really easy to remember. SA10. Welcome, Arpita. How are you, beta? Welcome to the class. That's very nice. You all guys are geared up to study. Let me see how many of you are really geared up to study. Because today I'm going to ask you questions as well. And yes, you have to answer in the chat box. So be ready for that. Okay, guys, so it's time to start for which we are gathered here. Yes, let us start the studies. So are you all guys ready? Ready? Pakka? Let me see how much actually you all are ready. Sab taiyar hain? Shall we start then? Chalo. So guys, can you see this boron and carbon family part 3? See, NCERT discussion is almost done, but there are still certain things which are actually supposed to be covered. If you talk about this borax bead test, that was not there in NCERT, but yes, it is an important part of what, guys? It is an important part of need. It does come. And yes, if you talk about your practical examination, there also it is equally important. So there are so many things which could not be covered in NCERT question, but yes, it is an integral part of the chapter if you go through. So here you are going to get a complete a thorough, you can say, discussion of the chapter. And of course you'll be getting tricks and trends also. I'll be sharing all the tricks and trends as well, guys. So let us start with ionization energy, guys. You guys all know what ionization energy, how it is related to Z effective, isn't it? Ionization energy is directly related to, directly proportional to Z effective and inversely proportional to atomic size. So this is, guys, the general trend, isn't it? But as we are doing what? We are doing boron family. Let me tell you, we are doing boron family, guys. And yes, carbon family. So we have to look ionization energy in comparison to them. Boron family, the trick to remember that is bag it, the brand name of, yes, the brand name for leather bags, GA गायब है. Yeah, this is aluminium, gallium, indium and thallium, guys. I hope it is clear to you all, guys. Pakka clear hai? Clear hai? Sure? Good. Now the second one is, look at this carbon family. Carbon, silicon, germanium, tin and lead. CSGSP, isn't it? So let's just see the trend of ionization energy amongst them, guys. So if you talk about boron family, yes, if we talk about boron family, see the trend of, as you move down the group and we say that ionization energy decreases, that all truly goes with S block element. I'm repeating that common trend truly goes with S block element, not amongst P block, neither amongst D block. But the reason, of course, are, yes, there every like either you talk about P block or D block, there is a proper reason which I'm really going to share today. So let us do the P block first. See what happens to size, guys. If you compare the size, ionization energy, we have already written it is inversely proportional to atomic size. So if you compare the size, no doubt beryllium is very, very small, after that aluminium, and yes, aluminum and gallium are almost similar size, or you can say, in fact, gallium is 3 picometer smaller than aluminium. In some book, like you'll be finding it is written as 3 picometer smaller than aluminium. So it is better to take it similar, not equal, but just similar like that. And after that, indium and then lead, guys. And remember, there is hardly few picometer. This lead is hardly few picometer bigger than indium. Okay, this is the size. So because of that, what is happening, the trend of ionization energy is somewhat like, see, no doubt boron being smaller, the no doubt ionization energy of boron is going to be very, very high. But because of this, sorry, this won't be lead any longer. Aji, This will be what, guys? Indium के बाद क्या जाता है? Yes, thallium. So this thallium just jumps over here, okay? And then gallium, which is much, much more, because you can see Z effective is very high, but size are almost same. Therefore, ionization energy of gallium is much, much more than that of aluminium, and the least one is of indium. I just want to give you a better trick for that. It is, let me change the pen now. It is, guys, B T G E. So this ionization energy, Hasomat, look at the screen now. But guys, this ionization energy, the whole, the actual, decreasing order of ionization energy is this way. Boron is having highest. Then because of that lanthanide contraction, which is thallium, and after that it is gallium, then aluminium and indium. So better you write it this way. But the gai, I'm repeating this: B for boron, T for thallium, G for galuminium, A for aluminium, and I for, yes, I for indium, guys. Now here what happens, guys, the size, if you compare, this is the order of size. No doubt carbon is smaller, then silicon, then germanium, then tin, and yes, just few, this lead is just few picometer bigger than that of tin. Therefore the exact order of ionization energy in this, see, this is the trend of ionization energy, guys. This is actually the trick. But gai, I'm repeating what happened. But gai, here the ionization energy order, guys, no doubt carbon will be having maximum, after that silicon, then germanium. But because just now you had seen, due to lanthanide contraction, the size is slightly increasing a bit. So a lot of Z effective is there. Therefore, ionization energy of lead will be a bit more than that of tin. This you have to write down. And how to remember this? This is what second, this is L for lead and L for last. But kaisa? And this is for second. So lead goes to second last. Yes, just lead jumps over just before tin. It's not this irregular as it is there in boron family, but yes, there is certain irregularity as we move down. Ionization energy decreases, but yes, lead is having a slightly more ionization energy than that of tin. Done है? आया समझ में? Take a screenshot faster. Good. Now let us see electronegativity, guys. This is very, very interesting one, isn't it? Electronegativity of boron family and carbon family. Let us compare them. मजा आ रहा है? लाइक कर रहे हो? फटाफट से लाइक करो. मजा तो तभी आएगा जब आप लोग लाइक करोगे और स्ट्राइक करोगे विद रिस्पेक्ट टू व्हाट. यस, व्हेन यू विल पार्टिसिपेट, तब ज्यादा मजा आता है बेटा. व्हेन यू रियली पार्टिसिपेट, then it seems that yes, you are studying something, you're getting something, and we also get energy out of that. Come on, all your eyes on the screen, guys. If you talk about electronegativity, the definition is very, very clear: the tendency to attract shared pair of electron towards itself in a bond. That's it. Okay, so boron family and carbon family, let us see how to remember the trick, or is there any trick or not, first of all, and if it is there, can we remember that or not? Let me tell you that. See, guys, in boron family, if we talk about B for boron, we know that is for bi. Bi means what? Two. We say binary. Bi stands for what? Two. So the electronegativity value of boron is what? Two. It is very, very easy to recall. Isn't it easy to recall? And after that, that of aluminium is 1.5. That is lesser than that of aluminium. And then again, if you move towards gallium, it is little bit more. And if you move towards indium, it is again more. And if you move towards thallium, that is again more. So right, this is 2, okay. And after that, 0.11, just keep on increasing, you will get the electronegativity value, isn't it? 15, 16, 17, 18. So simple to remember. Isn't it, guys? So simple to remember. But most of the time, electronegativity graph is asked in the form of graph. Yes, this is the graph of electronegativity, guys, with respect to what? Yes, atomic number of 13th group. I'm repeating. of 13th group. Can you tell me the trend of graph? Yes, the trend of graph. Let us draw this. See, suppose this is 2. This particular one, it is 1. Done. This is 5. I mean 1.5. This has to be zero point 0.5 then. Let us change the color of the pen now. Now guys, if you see the atomic number, say 5 here, and this is increasing this way. So boron will be drawn somewhere here. Will it be? Now just come to aluminium 1.5 here. Done. This is for aluminium. And as you are moving ahead here, so this will keep on increasing this way, isn't it? 1.6, 1.7, and yes, of course, 1.8. So the graph is kind of what shape? Yes, V shape कुछ बना? आया V shape? Is it V shape, guys? Okay, this way it will be. So the graph is V shape. Remember, if you find a V shape graph anywhere, straight away take for what? Yes, the electronegativity of boron family. It is V shape. Hope it is clear. आ रहा है समझ में? मजा आ रहा है? Okay, guys. Now let's just look for electronegativity of carbon. Carbon is how much? 2.5. Okay, and it is very very interesting to remember, guys. Boron and carbon family fighter. Welcome to the class. Boron and carbon family. We are just discussing the tricks and the trends. Welcome to the class, beta. Nice to see you. Come on, take all your pen and copy, and yes, your eyes on the screen. फटाफट से चालू कर लो. And yes, call all your friends. फटाफट से बुला लो उनको. फटाफट से, come on, guys. Without delaying, call all your friends. Ask them to be the part of the class. We are going to study boron and carbon in a very, very interesting way, guys. Okay, so all your eyes on the screen. So the electronegativity of carbon is how much, guys? 2.5. And that of silicon, germanium, tin, and lead. All of them are equal, guys. Yes, all of them are equal. That is 1.8. I'm repeating. All of them have equal electronegativity, which is simply 1.8. Welcome, Priya. आते जाओ फटाफट से आते जाओ. Call all of them. Okay, guys. So, what is the graph? Let us draw the graph here. Take atomic number this side, electronegativity this side. Suppose this is 2 and this is somewhat 1. So, 1.8 here. So, if this is for carbon, you'll be getting a graph just like that, isn't it? Because all of them are what? All of them are what? Having electronegativity equal. So guys, this will be what? The graph for electronegativity of carbon family. So this was V shape and this is what? This is what? Kind of L, ulta L kind of, isn't it? This way. I hope it is clear to you all, guys. This is really, really interesting because question can be asked this way also. As I told you that we have covered NCERT, but there are still so many tricks and trends which you are never, never going to forget. But yes, for that, all your eyes on the screen. आगे बढ़े. Done. Now melting and boiling point, guys. See, melting में क्या होता है? Gallium. Gallium is something which can melt if you keep it on a palm. तो गैलियम यानी गलना, गलना यानी मेल्ट. सो गैलियम को हाथ पे रखोगे इट इज गोइंग टू मेल्ट यानी गल जाएगा. गैलियम फॉर गलना. ओके, सो गाइस let us see the order, melting point order of boron family. It is very very easy to remember. You know what? Yes, what happens initially right from boron. Okay, boron का सबसे ज्यादा, it is very hard material, it is very hard substance, guys. Then aluminium, then gallium. But all of a sudden, you know what happens? Indium has more melting point. Then again, thallium also has more melting point. Now, how to recall this? Remember, guys, gallium has lowest one. So ऐसे तो कभी किसी को याद नहीं होता. This is the way in books it is written. But trust me, मुझे भी नहीं याद होगा अगर मैं ऐसे याद रखूंगी तो. So let me give you the trick. So batting, आजकल क्या चल रहा है? IPL, right? So batting, the exact order is BATING, where this is the exact order of melting point. कैसे याद रखोगे? Melting, batting, isn't it? Melting, batting. So boron has got highest, isn't it? Boron has got highest melting point, then aluminium, then thallium, then indium, and gallium is having the least melting point, guys. You know how much it is? Yes, it melts at 30 degrees centigrade. It melts at 30 degree. हमारे हाथ पे गल जाता है. गैलियम गलना, ग से गैलियम, ग से गलना. Okay, in your hand. I hope this trick is going to remember. Melting, batting, B से boiling point, B से boiling point, B से batting का trick. Boiling point का trick is given in terms of batting. Clear? Now look at the screen. This was melting point order of boron family. What about carbon family then? I'm repeating. What about carbon family then? Have a look. This increases. See guys, this happens what? Actually, this is what carbon is having almost like, if you talk about allotropes of carbon like diamond and graphite, they've got extremely high melting point. You know, almost 3370 degree roughly. This value might be differ by 20-25 degrees centigrade, but it is somewhat around this only, this much higher. Therefore, we say that this melting point decreases down the group amongst carbon family. Melting point decreases down the group. Okay, is this clear? But again, there is a slight change as it is the order is like that. Lead is having a little bit higher melting point than tin. Why? Second last wala order. ऐसे याद रखना है, second last. Lead is slightly more. So this is the order of boiling point, I mean melting point, guys. I hope there is no problem at all. And for boiling point, there is no issue. Boiling point what? It decreases down the group simply for both of them. Boiling point, क्योंकि जब melt करके you have separated the atom, now simply you have to vaporize it. So it decreases down the group. Done. Because boron and carbon, they're extremely harder, they're extremely compact, you know. Carbon is having a those 3D crystal lattice where each carbon is attached to four more carbon, and diamond is the you must have heard diamond is the hardest natural substance known on the planet. Yeah, so that is how you can recall it. Diamond has very harder, tightly packed, and has high melting point. So as we will move down, it has to decrease. Done. Now coming to density. Guys, density is what, you know, it is mass per unit volume. I'm repeating, mass per unit volume. So here volume, what is supposed to be, what we are supposed to say in terms of volume, we'll be looking for atomic size. And yes, this is atomic mass. And this atomic mass is going to increase down the group. This is going to, atomic mass, yes, increase down the group. Is it? And atomic size, you all guys just now had seen that as it is supposed to increase, because of additional shell, it does not increase, isn't it? It does not increase. So density is inversely proportional to size and directly proportional to mass, which is very well increasing. So what will happen to density if we talk about boron family? Density is going to, yes, going to increase down the group. Increase down the group. I hope it is clear. See, it is directly proportional to what? Mass. And we know as you move down, atomic mass increases. Ranjit is saying hats off for your dedication, ma'am. Thank you, beta. Thank you, guys. It is hats off to you guys that you are studying. Okay. Now, all your eyes on the screen. Thanks for the compliment. Now, look at the screen now. This is for boron family. Let us see what happens to carbon family now. Okay. So, here also what happens, guys, density here also the same thing. Yes, here also density increases down the group. Same concept. Okay. But yes, silicon is an exception. Remember, it is an exception because no doubt it is connected to four more, but lot of space is occupied without any use, without any proper packing. So volume increases abruptly. There is an abrupt increase in volume because of which density is, yes, density is lighter. I hope it is clear, guys. Now, guys, let's just look at another point. फटाफट से guys, come on, if you like the video, like तो कर लो, share all your friends, ask them to join us. Okay. Now look at the screen, guys. Type of elements. I'm repeating. Type of elements. What do I mean by that? Is if we talk about boron family, boron, then what? Aluminium, gallium, indium, and thallium, guys. See, this boron is actually what? Non-metal. Okay, where all of them are metal. But if you see for carbon family, what is there, guys? In case of carbon family, what happens? Tell me what happens in case of carbon family. Carbon, then silicon. Silicon is a very famous metalloid, isn't it? Then germanium. Abhishek Raj, welcome, beta. Welcome to the class. So nice to see you all, guys. Come on, you all guys study. पढ़ना है साथ में तो फटाफट से bring all your pen and copy with me. ठीक है जी. Now all your eyes on the screen. Then germanium and then tin. Then it is what, guys? Lead. Okay. So this is what, guys? Non-metal. Silicon and germanium are what? Yes, they are metalloid. And these are included under what, guys? Metals. So this is the meaning of type of metal under boron family and carbon family. You all guys knows that if we talk about a metal, if we talk about a metal, it has a tendency to lose electron. Non-metals either share or gain electron. And metalloids have certain properties similar to that of metal as well as some properties similar to that of non-metal. Okay. Now, coming to the most important feature of carbon family, and yes, what is that, guys? Catenation. You know what is a one line definition? First of all, let me tell you about catenation. Catenation is the tendency, yeah, self linking property of an element, guys. That is the tendency, thank you, beta. That is the tendency to form a long chain of itself. Ranjit is asking, ma'am, can you share the timetable of your class with respect chapters in community with timings? Definitely, guys, definitely. See, I come live daily at 2 p.m. On MWF, I take 11th class topic, and on TTS, I take class 12 topic. I take all inorganic, organic, and yes, physical. And as per the requirement of topic, I do take marathon session as well. Okay. And yes, this boron and carbon, as we have completed S block, then we have completed boron and carbon. So first I covered, all the topics with respect to NCERT, taking all consideration into NCERT topics. Now I am taking it with the vision of, yes, what all things could not be covered under that, but yes, at the same time should be known to you, because it is there in between the chapters. Not the question is might not be asked, but yes, the whole things is asked or discussed in NCERT. And remember guys, even if a single word is there in NCERT chapters, now as long as inorganic is concerned, because I told you in the beginning, as long as inorganic is concerned, you simply have to adhere to NCERT just as Bible. I'm telling you, just as Bible, you have to follow NCRT. And yes, 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 I went through the entire chapter and I tried to pick up every single word as well, which might not be covered in the exercise. And this lecture is to just give a, you know, kind of that touch. It is an just effort to give that particular touch to this chapter. And trust me, if you'll go through all part 1, part 2, part 3 of boron and carbon family video of mine, there is not a single thing left which is untouched and from which the question might not ask. There is nothing like that. So if you refer all these three video only for boron and carbon, all these lectures, that is sufficient enough, that is going to prepare you for all type of reasoning question, subjective question, MCQ, or any XYZ. You are able to do that. Okay, beta. Is that clear, Ranjit? If it is clear, give this. Now all your eyes on the screen, guys. So self-linking property. Now in order to form in order an element should have self-linking property. You know what is most required? Yes, the bond should be very, very high. So let me tell you what are the things required to show catenation. Ranjit is giving this. This is for you, Ranjit. Good. So, abhi fatafat say take your copy and pen, all your eyes on the screen, beta. And yes, if you don't get any point, come on, just write down that in the chat box. That ma'am, you just want to, you could not understand this particular topic or this particular word. Please explain it. Okay. All, and this is not for Ranjit only. This is for all you guys sitting over there. Okay. Now just have a look here, guys. So this is the self-linking property of an element. I'm repeating, self-linking property of an element, that is the tendency to form a long chain of itself. Is this clear, guys? So what property should have an element in order to show this property of catenation? First of all, guys, it should be very, very small in size. Okay. Then only more overlapping between the orbital will able to occur. That will result stronger the bond, and stronger the bond, yes, more longer will be the chain. Got it? So, and yes, if stronger the bond, that means what? High bond dissociation energy, guys. High bond dissociation energy. Is that clear? Apart from that, yes, beta, this is catenation. We are discussing what? Tendency to, we are comparing boron and carbon family, Ranjit. Boron and carbon family. So this is one of the property which is shown by that. And property wise we are covering. Okay. So high bond dissociation energy an atom should have. For example, we know that carbon has got maximum extent of catenation because the carbon bond is very, very strong, guys. Remember, very strong. And bond dissociation energy delta HBE for boron is how much, 348 kilojoule per mole. I'm repeating, it is 348 kilojoule per mole, which is sufficient enough to hold a long chain, to form a long chain of carbon. Okay, is that clear? पक्का समझ में आया? Is that okay, Ranjit? Is it clear, guys? So carbon has all these property, and that is the reason, guys, it has the tendency, it has extent, maximum extent of tendency to show catenation. Okay, is that clear? Paka, samajh mein aaya? And one more thing, guys, there is no lone pair over here. That is also one more reason. Because you'll be asked like, why doesn't nitrogen show this catenation? Very good, Abhishek and Ranjit. Very good, beta. I'm so happy that you all guys are studying. Arpita, well done. Sorry, let me take back to you there. So, guys, where were we? Yes, where were we were discussing the tendency of what? Tendency to show catenation. So you had just seen that carbon has got maximum tendency to show catenation. Is that clear? Is that clear, guys? Why? Because the bond dissociation energy is very, very high. I'm repeating, the bond dissociation energy is very, very high. Okay, and that is the reason it can form a long chain of itself. Okay, and not only that, if you talk about the entire carbon family, I'm repeating, or if you talk about the entire carbon family, it is only lead which does not show catenation. Make a star mark. Lead, L for last, L for lead. Only the last element does not show catenation. Otherwise, all the other element, they show this tendency of catenation. Is this clear, guys? All other elements shows a tendency of catenation. Same reason, Abhishek, same reason. See, all of them, the bond dissociation energy is very high, so that they can form a long chain of itself. But as you know, lead is much bigger in size. Will the orbitals may not be able to overlap that way, and it is a metal also, you know that there's no overlapping kind of thing possible over here. And yes, what metallic bonding is there, and that is why this cannot hold like a chain, because lead is more like what, metal. Therefore it do not, it does not show catenation, guys. Is that clear now? Pakka? Pakka it is clear? Sure. If that is clear, let us discuss one more thing, guys, under it. But the physical properties will change. That is allotropy, guys. Is that clear? Now, carbon shows so many allotropes, amorphous and crystalline. If you talk about crystalline, it is diamond, graphite, fullerene, which we have already discussed in the previous lecture, under lecture 2 of boron and carbon. Now, let me tell you the reason. Why does it show allotropy? Again, guys, if an element will show allotropy, remember, it should able to show the tendency of catenation, which is very much there with carbon family elements. And you had just seen that with carbon it is maximum, isn't it? Apart from that, it should able to form, yes, pi pi bond, that is also with carbon a lot. And yes, it should have high bond dissociation energy, which is in fact the part of catenation only. Because if high bond dissociation energy will be there, then only it will show catenation. So all these are together decide whether the element will show allotropy or not. And you have seen that in case of diamond, this is too much. This property is majorly shown by all these properties there with carbon. Therefore, carbon shows maximum, yes, maximum allotropes, isn't it? Now, coming one of the important point, guys, I just want to tell you that carbon. See, all family, all members of carbon family, all members of carbon family shows allotropy. Yes, this shows allotropy, guys. This is very very important. All carbon family. ये बहुत इजी है रिमेंबर रखना, बिकॉज वी नो डायमंड ग्रेफाइट, जहाँ पे बोलते हैं ना जिस घर में इतने अच्छे अच्छे लोग हो तो उसका नाम बहुत होगा. Similarly, the carbon family which is having all, you know, diamond, graphite and all, so the entire member shows allotropy, guys. Okay, now coming to boron and carbon, I'm repeating, boron and I mean boron family. In this boron and thallium, guys, only the and the last first and last member, they show allotropy. And you can say that the reason for this is not very much known, but yes, you can take it under exception. I told you na, for most of the exception you'll be getting a reason, but there will be some for which like you have to compromise with the reason. So आप ये याद रख लो that first and last, like boron and carbon family, whenever we study them, we study a comparative study, we go for a comparative study. So in carbon family, all of them are showing allotropy. तो इज्जत बचाने के लिए यहाँ पे क्या करते हैं, जो बड़ा और छोटा मेंबर है वो इन घर की इज्जत बचाते हैं. And yes, yes, they show what, allotropy. Okay, is this clear? I hope you're not at all going to forget it, guys. चलिए आगे बढ़ते हैं. Now coming to chemical property, guys. Under that, the first one is, if you talk about boron, boron form, yes, BCl3, BBr3, BF3 and all. What are these compound? Yes, these are electron deficient one. Electron deficient one. If you talk about aluminium, it forms AlCl3. AlCl3 is known to form a dimer. I'm repeating. In vapor phase, this is known to form a dimer, guys, like this. AlCl3. This is the AlCl3 unit. No doubt, it is what? Electron deficient. Octet is not yet done. So what will happen? You just draw the back bonding with this pen. So what happens? See guys, empty orbital are still there on aluminium and lone pair present here. So there is a back bonding forms here, which is actually going to hold the 2Al3 unit as dimer. I'm repeating, this is going to hold 2Al3 unit as dimer, guys. Done. आए समझ में. It exists in vapor phase. Okay. Now let us do one of the very important reactivity of boron. Let me erase it first. Yes, guys. See, we have been studying, we have been telling that diamond is the hardest natural substance known far. Isn't it? Isn't it? But yes, I'm going to tell. Can you tell me what bulletproof jacket are made up of? Bulletproof jacket are made up of. Tell me. डायमंड का बना सकते हैं क्या? बिल्कुल नहीं. इट्स वेरी कॉस्टली, इजंट इट? डायमंड का जैकेट पहनोगे, कैसे पहन पाओगे बताओ? इट शुड बी मैलिएबल एज वेल. So very simple question, isn't it? So bulletproof jacket, guys. What are bulletproof jacket are made up of? Can you tell me? Yes. See, boron. Boron, very very interesting compound, guys. See, boron, amorphous form of boron reacts with air, and this form B2O3 like this, which is, yes, acidic. It also reacts with N2, and you know what does it form? This is called as boron nitride. I'm repeating, this is called as boron nitride. And yes, this bulletproof jacket are very well made up of that, guys. It is very very hard. तभी तो bulletproof. Bullet भी will not able to what? Pass through. That is the meaning of bulletproof. So boron nitride, this jacket, bulletproof jacket are made up of boron nitride. Okay. Okay. So no, beta, don't do one thing, just write down your proper doubt. If you are having any doubt, not these things यार, है ना? अभी ये वाले इसके लिए I'll keep a chat show separately. We'll be chatting together. Don't worry. Let's study now. So guys, just look at this boron nitride. You know, this is also called as, I'm repeating, this is also called as inorganic graphite, guys. You know that this graphite is very very hard substance, guys. This is very very hard. And yes, graphene sheets, suppose these are the graphene sheets, they are attached together by, attracted together by van der Waals force of attraction due to the valence, free electron over there. This is what graphene sheet. Okay. What happens here in case, if you look at these sheet from top, you'll be finding that this type of hexagonal rings are there. And yes, on every carbon there is one electron free. Is this clear? There is, on every carbon there is one electron free. Let me show you with that. And yes, this is on lower layer like this. Because of this, yes guys, because of this, what? Because of this, it is a good conductor of electricity. But remember guys, there is one more important point about it. If these electrons are present just lower side of the sheet, so what happens along the sheet? I'm repeating, along the sheet, they're very good conductor of electricity. But perpendicular to this, They behave as semiconductor, remember, because they are present below the sheet. So along the sheet can electrons can flow very easily. But if you talk perpendicular to that, they are not. Yes, they are not that good conductor. Okay, so that is one of the very important thing about graphite. So you must note it down. Hope you guys must have noted down that. Now let us look why this boron nitride is called as inorganic graphite. Let me tell you the structure of this, guys. This N B N B N. This is how they are attached, like that. B N B N. Is this clear? Here what? Yes. Here. Oh, this is, guys, okay. Now here this will be attached to B. B like this. Is it? Now what happens? First of all, connect a bond, single bond. Connect all of them by single bond like this. Done. And then just make a, because the octet of boron is not completed. So what happens? Yes, the bond goes like this. Okay. Is this clear? Is this clear, guys? सबको आ रहा है समझ में? From nitrogen to boron side, same here. Okay. From nitrogen towards boron, here also, here also. Is this clear? Okay. Let me draw this somewhat differently. This is nitrogen. Is this clear to you guys or not? Now draw boron here, here boron, here nitrogen. This way they are attached, guys. Isn't it? Ye wala idhar, this will form, this particular bond will form this side. Okay, is it done? I hope the pen color is okay. If not, then let me know. Is this clear, guys? So same thing happens here. Done. आ रहा है समझ में? This is how, because of this type of bonding, guys, this is very, very strong. This boron nitride is actually very, very stronger, guys. I'm repeating, because of this boron nitride, because of such type of bonding here, okay, this is very, very harder, and therefore it is used in bulletproof jacket. And you can see, because of the similarity to the structure of, yes, here also what happened, such type of pi bond is there, isn't it, at each carbon atom. So because of that, the similarity, this is called as inorganic graphite. I'm repeating, because of the similarity to the structure, it is called as inorganic graphite, guys, which is very, very hard. This is very hard structure. Done. Clear है? आपने अभी तक, if you have not the video, come on, like it, guys, without any delay. Faster. jaldi se fast, all you guys. Nice of you. So let us go ahead with another chemical property, guys. See, boron. Let us see reaction with acid and alkali. First of all, remember boron. If it is in crystalline form, if it is in crystalline form, guys, it is coated. It is coated with a layer of B2O3. That makes it protective. You can say that does not let it react with anything. In order you want it to react, you will have to take amorphous form. Is that clear? Is that clear? Because such, hard layer no longer exists over there. Done. And then it will react, guys. Now if you talk about the reaction, see, it will react with oxidizing acid like H2SO4. It will react with like nitric acid. Yes, it will react. And yes, boron as sulfur. Sulfur get oxidized to sulfuric acid by reacting with nitric acid. Same way boron. Same way boron get oxidized to boric acid, guys. With both sulfuric acid as well. But here H2SO4 is there, so another one will be SO2. Here NO3, I mean nitric acid is there, so NO2 will be released. So the important one is boron get oxidized by oxidizing agent and forms what? Boric acid. Is this clear, guys? Now, similarly, let us look for aluminium, guys. It is said that aluminium can be kept, like in aluminium, you can keep this nitric acid. You know why? Because on reaction with the nitric acid, suppose this is the container, as soon as you drop HNO3 into that, so all the element present over here, guys, the surface layer it of aluminium reacts with HNO3 and forms Al2O3 layer. That actually prevents further reaction between these two, and therefore it acts as a protective layer. It does not let them react. And this is how you can keep nitric acid very well in a container of aluminium. I hope it is clear. Done. Okay, that's very nice. Okay, guys, आगे बढ़े. Done. Now, guys, one of the important reaction of it is with that of sodium hydroxide. Let us see them now. What happens if you talk about a reaction of boron with sodium hydroxide? Raj Patel, welcome to the class. Raj Patel, how are you, beta? Yes, I took your name twice, Raj Patel. कैसे हैं आप? How about your studies? पढ़ रहे हो? Call all your friends. Ask them to study here. Yes, call all your friends. Okay, guys, look at the screen. Copy pen लेके बैठ जाओ बेटा in front of the screen. We are studying together. We are just going to study together. Okay, guys, NaOH is there. If we talk about NaOH here, very good, Raj. This is for you if you are going to study. See, guys, boron on reaction with NaOH. I'm repeating, boron will react very much with NaOH, guys. Is that clear? And yes, with NaOH, boron will first, if less dilute NaOH is there. It's okay, beta. Now all your eyes on the screen. Study. Yes. बहुत बढ़िया. Very good. This is for Raj once again. Happy? Now, all your eyes on the screen. So this boron reacts with NaOH, guys. Is this clear? If it is dilute, it will be reacting this way. Sodium metaborate, and yes, hydrogen will be there. And yes, this happens with what? 2 moles or dilute, you can say. Less concentration. And if more concentration will be there, guys, this will be forming Na3BO3. I'm repeating Na3. This is sodium metaborate and this is sodium orthoborate. This is sodium orthoborate. Is that clear? And of course, H2 will also be produced over here. Is it clear, guys? Now let us see how does aluminium behave with NaOH. As aluminium is amphoteric, it also reacts with that. And if dilute concentration is taken, it will be forming sodium meta-aluminate and hydrogen will be there. Remember, very, very important reaction, guys. This is asked, this reaction, ये reaction will never, never leave you. Whether you talk about qualitative analysis or you talk about metallurgy or you talk about S block element or you talk about boron carbon family, this is always going to follow. Don't worry. So all your eyes on the screen, guys. Now, if you will take concentrated NaOH here, what will happen? Yes, guys, it will form Na3AlO3. Yes, Na3AlO3. This is what? Sodium orthoaluminate. Is this clear, guys? And yes, in both the case, remember, in both the case, hydrogen gas is being produced very well. I hope it is clear, guys. आया है समझ में? Good. Now let us see chemical properties of carbon. Carbon, guys. Carbon, it is a non-metal. It is a non-metal, guys. Isn't it? Carbon. Carbon actually, with limited oxygen, it forms CO2, which can act a very strong ligand. Limited oxygen, excess oxygen, it will form what? CO2. This is an acidic oxide, whereas this is a neutral oxide, guys. Done. Is this clear? Now let me change the color Let us see that of lead. Lead with conc HCl, guys. With conc HCl, it will form what? Yes, it will be forming PbCl2 and H2. Okay. And what will happen when you add conc, when you add concentrated H2SO4? I'm repeating, I'm covering all those questions which are very, very important, guys. This you will be finding, this particular one you'll be finding in electrochemistry. So what happened? This forms PbCO4. And what happens soon after formation of PbCO4? PbCO4 forms a coating over it. Okay, and the reaction just stops. Remember, a coating, if you want it to react, you have to remove that coating, and that actually happens during electrochemistry. Lead acetate battery, do you remember that? Yes, deposition of PbSO4 over there, and that is only removed out by discharging. Good. Now guys, let us see few more reaction. One of the very interesting reaction of graphite is, this was asked also, that is the reason I am covering. Graphite is, yes guys, with HNO3, hot and concentrated HNO3, this forms what, this forms मैलिटिक acid. कैसे याद रखोगे? Graphite है, carbon है, make a benzene ring like this. Done. Now this benzene ring is supposed to attach to 6 hydrogen. Okay, and concentrated nitric acid is a strong oxidizing agent. So remember this, that instead of hydrogen, what do we get? We get COOH everywhere on the ring. बहुत सुंदर सा कंपाउंड बनता है. Yes guys, what is the name of this? Malitic acid, not malic acid. Remember, this is malitic acid. This one is malitic acid. Is this clear? Malitic acid. Remember, this was asked that what happens when graphite is heated with concentrated nitric acid. Guys, malitic acid forms. What happens? Malitic acid. Where? How do you remember the structure? Make a benzene ring. And yes, on instead of hydrogen, just put COOH group. Is this clear? Just put what? COOH group. Hope it is clear, guys. Now just look for what happens in case of, if you add HF and HNO3 together, guys. It is going to give you what? Graphite oxide. If you take only HNO3, you'll be getting malitic acid. If you take along with that, if you take HF, you'll be having what? Graphite oxide. I hope this is all done, guys. आगे बढ़ें. Just if you want, take a screenshot. We're going to go ahead. There is a question on the screen, guys. White fumes appear around the bottle of anhydrous aluminum chloride. Give reason. Suppose this is a, all these chemicals, where do they store? They are stored under bottle like this, which we call as Winchester bottle. कुछ ऐसा दिखता है? Yes, we call them as Winchester bottle, guys. So suppose anhydrous AlCl3 is stored over here. What will happen? White fumes. Let me take white color over here. From here you will be finding white fumes keep coming. Why? Can you tell me why? Because aluminium chloride has a tendency, I'm repeating, has a tendency, guys, what? To get hydrolyzed with atmospheric moisture. I'm repeating, this has a tendency to get hydrolyzed. And yes, it forms what? AlCl3. And this are atmospheric moisture. This forms plus, yes guys, plus HCl is forming. And HCl, when it forms, it appears as fumes. I'm repeating, this appears as fumes. Okay, guys, is that clear? So these fumes appear from here, because of which it looks like what? White fumes are coming out from the bottle. So AlCl3, because of very high charge density of Al3 plus ion, it has a strong tendency, yes, it gets hydrolyzed with water, guys. Hope it is clear. Come on, note it down. Now the very same kind of question but asked in a different frame. Anhydrous AlCl3 cannot be prepared by heating hydrated salt. Very, very important question here, guys. Aluminium chloride. Aluminium chloride is present as its hydrated salt like this. Okay. And it seems like generally what happens? We feel as if CaSO4 2H2 is there. When you heat it around 200 degrees centigrade, what happens? You get CaSO4. You get CaSO4 anhydrous, and water vapor are evolved like this. You get anhydrous CaSO4. But if you will heat this, you won't be getting simply AlCl3 and 6H2O vapor. This won't happen. Why? Because of very small size, you can say, or high charge density, it has a tendency to polarize water molecule. And when you try to heat it, or when you try to, bring out the water molecule or remove the water molecule by heating, it just get hydrolyzed. It gets hydrolyzed, guys. And yes, after hydrolysis, what does it form? Al2O3, HCl, and H2O. This HCl vapors are produced this way. Is this clear? आया समझ में? Note it down. Just note it down, guys. जल्दी से. Now the most interesting one is borax. Let me tell you about this. This borax is, guys, what? It is in Hindi called as suhaga. Yes, it is suhaga. बोलते हैं ना, सोने पे सुहागा. What does that mean? Actually melting point of gold is high. When you add this borax to that, it decreases the suhaga. It decreases the melting point of gold. Okay, guys, which is used, and also you can say it is used in purifying gold as well. Okay, guys, and this is a white crystalline solid, guys. First thing, it is used to decrease melting point of gold. And how does it look like? White crystalline solid. Is this clear? You have to remember this, guys. Structure we have already discussed in my previous video, okay, under NCERT question, guys. So I told you that I'll be covering all those things which we have not covered, okay, but is there in NCERT, is very, very important as per NEET is concerned. So therefore this lecture is because of that. And those who really want to know the structure, how the structure is to be written, do one thing. The link for my previous video is there in the description box. You should watch that. Pakka? Good. And yes, agar kuch questions hai, kuch explain karna hai, if you want to tell, you can message me also. Okay, guys, all your eyes on the screen. Now, one of the very, very important thing about it, when you dissolve this in water, it forms alkaline solution due to formation of NaOH and boric acid. That is all clear, guys. Okay. Now, its heating action is very, very famous one, isn't it? And this is also used as what? It is used to used in this, what do we say, qualitative analysis. Okay. So let us see this Na2 before O7, Na2 before O7, yes, dot 10H2O on dissolution with water, guys. What it is going to happen? Yes, it will form NaOH, and this is a strong base, so the aqueous solution is very well alkaline in nature. Done. आगे बढ़े. Now heating action of borax. There are some dramatical sequence under this, dramatical sequence. Let me cover you that. Let me cover you that, guys. Okay. Thank you, Praveen. Thank you so much, beta. Nice. That's really nice of you all, guys. Now, all your eyes on the screen, guys. Heating action of borax. So, what happens when you heat borax? Padai karo, padai. All you guys, come on, have your eyes on the screen first. So, when it swells up. So, pehla, the very first observation will what? Borax will swells up. It will swell up. Is that clear? And when you continue heating, even at higher temperatures, say 740 degrees centigrade, it converts into a transparent glassy bead. The whole, guys, sodium metaborate and B2O3, the entire mixture is actually what? Transparent, glassy bead, gas. And remember, this is very, very important if we talk about qualitative analysis. I'm repeating, this is very, very important if we talk about qualitative analysis, guys. Okay. Now let us see borax bead test, which is actually I was just talking about. This borax bead test is used to, I'm repeating, this is used to identify many of the transition metal. Used to identify many transition metal like this, guys. Okay. So let us see what actually happens. First of all, this borax is taken in a spatula. Suppose this is a spatula like this. We take borax in it, we heat it, and finally we get what? Glassy bead-like structure like this. Okay. After heating, it forms glassy bead-like structure. To that we add, salts of different metal, and then again we heat salts, and then again the mixture is heated, and we find specific color, guys. Okay. We, for example, if we talk about, let me change the color. If we talk about test for cobalt, suppose you add here cobalt sulfate. Always remember, first borax is taken in the spatula, then it is heated into glassy bead, and in molten state only cobalt sulfate or any salt which is to be tested is poured into that. Okay. Then at that high temperature, this cobalt sulfate will also undergo what? Decomposition as cobalt oxide and SO3. Is that clear? Is that clear? And yes, this borax is melting over here, guys. So that B2O3 is also going to react with it. Now this together going to form what? They together going to form cobalt. What is it? Yes, this is cobalt metaborate. Okay, is it clear? So this cobalt metaborate is cobalt blue in color. We say color cobalt blue. It is cobalt blue in color. Okay. So if you don't know what cobalt sulfate is, suppose you have taken a particular salt and just after going through this process, if it is turning blue, you will come to the conclusion, yes, it is what? It can either be cobalt or it can also be copper. Yes, guys, it can also be copper. So there are different, like you can test nickel, you can test chromium, you can test manganese, you can test iron. Okay, so you will be taking their salts, hitting it with a glassy bead, and yes, after that particular final color of that particular metal uh, metaborate, you'll be coming to the conclusion, yes, this can be this transition metal or this can be this type of transition metal. I hope it is clear. So I have made a very easy trick for that, and that is IMNC, multinational company. So IMNC, there are many like who just say भैया मुझे किसी से डर नहीं लगता, I myself MNC. So IMNCs, C's, IMNCs. Done. This I for iron, this I for iron, M for manganese, N for nickel, and there are three C's, guys. How many? There are three C. Okay. First one is for chromium, cobalt, and yes, copper. You can take them cobalt, any C for cobalt, copper, or chromium. There is no trick for that. Don't worry. But yes, these three C transition metal are there: chromium, cobalt, and copper. I'm repeating: chromium, cobalt, and copper. Done. ठीक है, आ रहा है समझ में? गुड. बढ़े आगे. Yes. So what is the color of iron? You know that if it is Fe, this 3 plus, it is reddish brown in color, isn't it? And that will get somewhat lighter up when glassy things will be mixed to that. Won't it be? It is. So the color of iron metaborate is yellow. ब्राउन में थोड़ा सा व्हाइट टाइप का कुछ मिलाओगे तो व्हाट विल हैपन? येलोइश टिंज. That way you can remember it. And it is all a universal fact that KMnO4 or manganese salts are what? Yes, they are pink in color, guys. Pink, or you can take the dark violet kind of. If it is dilute pink, if it is concentrated, it will go towards the violet shade. Okay, guys. And if we talk about nickel, we just write it as brownie. I'm repeating, brownie. Brownie खाते हो आप लोग? मजा आता है? What is the color of brownie? Yes, chocolate brown, isn't it? So similarly, brownie, nickel ka brown. Now coming to this chromium. This chromium is doesn't look like green. अपन जब whenever we write down green, we write it this way. So chromium ka CR or G ka GR, is that okay, guys? Green. And this is what? Cobalt. Cobalt is cobalt blue, guys. Okay. Cobalt is cobalt blue. And of course, copper is also blue. So copper and cobalt both are blue. Paka? Will you forget it? That's very nice. So how to recall this borax bead test? IMNCs. I'm repeating: I for iron, M for manganese, N for nickel, C for chromium, the other C for cobalt, and one more C for copper. याद रहेगा borax bead test. So first of all, borax bead test is done to identify, yes, some transition metal, and that too we go for the color. And yes, this all is done in oxidizing flame, guys. Remember, these are the colors shown here is in oxidizing flame. What is oxidizing flame? Suppose this is the flame, guys, and this is the whatever inside of the flame. The inside part of the flame is actually yellow and outer side is moreover, I mean, bluish tinge. Why? Why outer side basically blue? Because complete combustion take place. There is no unburnt particle because a lot of oxygen is outside available. And inside, guys, unburnt particles, carbon are there. And with presence of carbon, that particular element can undergo what? Reduction. Clear? reduction. Is this okay? Is this okay, guys? Done. So outer side of flame will be called as oxidizing. That is the reason, as there is no unburnt particle, and inner one is, yes, having unburnt particle. Therefore, guys, reducing flame. And yes, guys, one of the very, very important thing I'm going to tell you is this particular zone of flame, remember, is the hottest one. I'm writing here. This particular zone is the hottest one, guys. Hottest zone. Okay? Sure? आ रहा है समझ में? आगे बढ़े? Done. So this is all about borax bead test. If you want, you can take a click. जल्दी से click ले लो. And अभी तक वीडियो लाइक नहीं किया है तो just like the video, guys, fast. Don't wait any longer. Like it. Now coming to boric acid. Yes, guys, boric acid is what? It is a white crystalline, yes, white crystalline solid with soapy touch, slippery. That is the reason it is used in, yes, it is used as this carom board powder, guys. It is used as carom board powder. Yeah, because it is soapy to touch. It, because of the hydrogen bond, this can, this reduces the friction. They slip over each other. Is it? That is the reason it has got a soapy touch, and it is used in carom board powder. At the same time, it is very antiseptic in nature. It is used to eye as a, eye wash as well, guys. So if we talk about its solubility, guys, it is sparingly soluble. Always remember. And yes, but if you will heat that particular water, then it is going to dissolve very nicely, because of course hydrogen bond is there. But in cold water, it may not get dissolved properly, because a lot of hydrogen bonds are there with each I mean, the hydrogen bond is there amongst the molecule itself. So as you increase the temperature, the hydrogen bond, these molecules of boric acid, they form it with that of water. And that is the reason with increase of temperature, the dissolution increases, okay, with water. Is that clear, guys? Pakka, it is clear. Good. Now, how they are prepared, you will take borax and yes, add any mineral acid like either H2SO4 or, guys, HCl. You will be getting a white powder that is nothing but what? Boric acid. White powder, I mean precipitate of that will be forming. Is that clear? Structure I already told in my previous video. Link for the same is given in the description box, guys. आगे बढ़ते हैं थोड़ा. One of the very, very important point about is, guys, this boric acid cannot be titrated satisfactorily. See, no doubt this is a very weak acid. And you know that generally, like if you talk about strong acid, just by using any indicator like phenolphthalein, it can be easily titrated HCl versus NaOH with the help of phenolphthalein, isn't it? Isn't it? Is it clear? Yes. So we'll get a exact endpoint. We'll be getting an exact endpoint, and therefore they can be satisfactorily, yes, they can be satisfactorily titrated. Whereas if you see the case of boric acid, if you directly take instead of like HCl, if you take there as boric acid and you just want to titrate it with that of NaOH, you won't be getting a satisfactory endpoint. Okay, guys. Now tell me why there is no because there is no sharp endpoint. No sharp. Yes, let me take the eraser here, guys. No sharp endpoint, guys. Is it clear? No sharp end point. So what happens in that case, guys? What happens there? How can we get a sharp end point? when you use a compound like such organic compound like polyhydroxy diols. I'm repeating, when you take polyhydroxy diols with boric acid. See, first of all, just take a conical flask, add boric acid, and then drop polyhydroxydiols. Okay, and then use any acid base indicator and then go for titration. You will get a sharp endpoint. Let us see why does it happens. Say for polyhydroxydiols, say for example, polyhydroxy can be anything like, yes, it can be any sugar like substance, won't it be? It can be mannitol, glycerol, yes, catechol, salicylic acid, all they have that. So what will happen, guys? This have, yes, it should be cis diol, that is OH should be present first of all on the adjacent carbon, and that too in the same side. And yes, boric acid is there, H3BO4, I mean H3BO3 is there, sorry. So that you have taken, isn't it? So what will happen because of these unit? You can see this hydrogen, it is going to do what, first of all, when you add the mixture like this and then you titrate it with that of NaOH, okay guys, what will happen? First, this is going to react with that of NaOH, okay, and this together will form what? Let me change the color of the pen here. See, H3BO3 लेना है, this, and yes, cis diol type of polyhydroxydiol you have to take, and then just take NaOH in the burette, add phenolphthalein in the this conical flask, and then just go for titration. You know what will happen first of all? Let me clean it first. First of all, what will happen? Boric acid are there, will react with NaOH, which actually when you don't take them, it is supposed to react this way. NaBOH4 complex, NaBO2 and water. Done. Is this done? Okay. And when you take this type of cis diol, then what happens, guys? Then what happens? This CH, OH are there, which are attached to like this. This boric acid. First, see, without a cis diol, this will happen. Okay, this will be forming, no sharp endpoint with that. But if you add this type of cis diol to them, first of all, what will happen, guys? CH, see, this way they are going to connect like this. Let me take an eraser first here. Yes, let it be this way. यहाँ तक तो सेम रहने दो. Here also just draw a OHCH like this. And what happens, this boron, yes, it forms a bond like that. Okay, guys, this is how the cis diol are reacted with this. And guys, this is very much in equilibrium. Is that clear? Is that clear, guys? Is this clear or not? So when organic polyhydroxydiol, as you have seen here, is added, what exactly happens, boric acid start behaving as strong acid, as had it been like HCl is a strong acid. When you titrate with NaOH, you get a sharp endpoint. Same thing happens over here. With this, they reacted this way, and boric acid start behaving as a strong acid, or you can say strong monobasic acid, that it is able to lose one proton, and therefore it can be titrated satisfactorily using phenolphthalein as indicator. Is that clear? Is that clear or not, guys? Good. आगे बढ़ा जाए. test for borate radical. Very, very important, guys. See, you'll be finding this amongst qualitative analysis, phosphate, borate, how to go for a test for phosphate radical. For phosphate radical is very simple. We take, ammonium molybdate, isn't it? Entire, first of all, what? A compound containing phosphorus is converted into lessons extract. Then entire phosphorus is converted into phosphoric acid. This is further acidified with HNO3, and yes, after that ammonium molybdate is added to that, and we get a yellow precipitate of ammonium phosphomolybdate. That we'll be doing later, but let us see what is how the test for borate radical is done, guys. All your eyes on the screen. So how it is done, guys? First of all, we take B boric acid, then HF like this. Let me tell you one thing, that we are first not going to start from here, rather borate radical. See, we have to test for borate radical straight away. So what we will be doing, we'll be taking boric acid powder. We will mix that with ethanol. I'm repeating. This is mixed with that of ethanol. And yes, after adding ethanol, you know what will happen? This will be forming, guys. This will be forming. What is it? What is it, guys? Yes, this is ethyl borate. I'm repeating. This is ethyl borate, guys. And remember, alcohol, you guys know that alcohol are extremely volatile. I'm repeating, alcohol are extremely volatile. Same, this ethyl borates are also volatile. Ethyl borates are also volatile. Is this clear? Now what happens, guys? Evolved gas. See, this is volatile, no doubt. And when you just burn this, bring it to the flame, this ethyl borate burns with a green edged flame. How does it look like? Let me draw that. Suppose this is the flame, guys. Okay. From outside, this will be like this. This is the meaning of a green edged flame, guys. Green edged flame. I'm repeating how to do this. Take boric acid on a spatula. This is the spatula. Add a pinch, add a few drops of ethanol. Add a few drops of ethanol. Okay, this will be forming ethyl borate, and then just to this spatula bring flame like this. Burn it. This is going to burn like green edged flame. I'm repeating. This will burn with a green edged flame. Okay. So suppose you don't know any XYZ can be here. This one can be any XYZ. Add alcohol in order to go for a borate radical test. Add ethanol to that. I'm repeating. Add ethanol to that. Is that clear? Is that clear? Yes. So you have added ethanol to that, and then just burn it. If it is burning with a green edged flame, that means yes, what? Borate radicals are confirmed. I'm repeating, borate radicals are confirmed. Note down, guys, note down faster. कर लिया नोट? चलो आगे बढ़े. Now there is a question on the screen. BF3 does not hydrolyze completely, whereas, I'm repeating, BF3 does not hydrolyze completely, whereas BCl3, BBr3 get hydrolyzed to form boric acid and HX. Why this is happening, guys? You guys know that if you compare the size of fluorine, okay, so fluorine, say bigger is what? Chlorine. Further, bromine is bigger than that, and iodine. So this is the size of these halogen atoms, isn't it? So if you look for BF3, it looks like this, a planar molecule. But yes, there is an empty 2p orbital, guys, here. And here a filled orbital. Yes, here lone pairs are there, filled orbital. So there is a back bonding like this. Back bonding like this. Is it? Because of that, this BF3, the Lewis, strength of Lewis acid property of BF3 is lesser. Because of this only, because of this back bonding. Because in this case, 2p back bonding is there, guys. Okay. Whereas if you talk about BCl3, 2p 3p back bonding. Here 2p 4p back bonding. If you'll go for, yes, BBr3. If you go for BI3, guys, this will be 2p 5p back bonding. Is this clear? If you go for this one, it will be 2p 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 back bonding. Done. Here 2p 3p back bonding. Here 2p 4p. Here 2p 5p back bonding are there with increase in size. And you guys know that, similar the size of the overlapping orbital, more is the extent of overlapping. I'm repeating, more is the extent of overlapping. Very nice to see you all guys here. बहुत अच्छा. Very nice of you all guys. Thank you for the compliment, guys. I hope you all guys are studying very seriously. Sure. Okay, that's really nice. So let us go back here, guys. So if you compare the strength of Lewis acid character, that strength will be what? BF3 is least, then BCl3. More the overlapping, less will be the requirement of further electron from someone else, isn't it? Similarly, BBr3, and then this is the order, guys. So this is all done. But this question is asking BF3 does not hydrolyze completely. So actually this is again the reason for that as well. Because you can see that there is what? Back bonding, guys. And therefore because of the back bonding, this is more stable. This is more stable. Is it? And as they are not, this extent of back bonding is not that stronger in all of them. So they are not that stable. They still want something, isn't it? They still want something and they easily get hydrolyzed. I'm repeating, they easily get hydrolyzed into boric acid and HX because of this only. Okay, guys. Now come to boranes. Let us see boranes. Not diboranes, boranes. As we go for alkanes, we do study alkenes. What are alkenes, guys? CnH2n plus 2. They do have a general formula. They do have an IUPAC name. So these are, alkane. And analogous to that, these are boranes. But instead of carbon, here you'll be having boron and hydrogen. In alkenes, what do we find? Carbon and hydrogen. And in case of this, what do we find? Boron and hydrogen. So they are boranes. So basically what these are? Yes, these are binary compound. I'm repeating. Let me change the color of the pen. These are, guys, binary compounds. Okay, these are binary. Binary means what? Having two elements. So what two elements are? Boron and hydrogen. So borans are basically binary compounds of boron and hydrogen, guys. Is that clear? Is it clear? Now these follow two series. These follow two type of series, guys. One is series 1, the other one is series 2. Now, what are there under series 1? These are actually called as nido boranes. I'm repeating, these are called as nido boranes. And what they do have a general formula like this hydrocarbon have. And what is the general formula for nido borane, guys? BN Hn plus 4. I'm repeating the general formula. Welcome, beta. Welcome to the class. Shruti, welcome to the class. Srishti, Akansha. So nice to see you all, guys. Nice. Very nice. पढ़ रहे हैं सब कोई? That's really great of you all, guys. Now, all your eyes on the screen, guys. So, the formula is, guys, BnHn plus 4. Similarly, series 2 is arachno. I'm repeating, arachnoboranes. With the formula BnHn plus 6. See, here it is N plus 4 and here it is N plus 6. Arachnoboranes. And this is simply nidoboranes. What is it, guys? Nidoborane. Is this clear? Now, guys, diborane B2H6. Suppose if N is 2, this will be 2 plus 4, that is 6. So, diborane is a variety of nidoborane. Is that clear? And suppose if you take 5 here, 5 plus 4, this will come out as H9. Is it? Now, look here. If you take B4, N as 4, H is going to come 4 plus 6, that is 10. Will it be? Take B5, so 5 plus 6, this will be. Hello, Alok, welcome to the class, dear. How about your studies? All good? Nice. So, guys, if it is 5, this has to be 5 plus 6, 11. So, can you see? This is also C5, this is also C5. Isn't it? Both of them have, this will be B, guys, boron. Okay, so both of them have B5. Fine. What about studies? If it is all good, come on, give this. That's nice. So, guys, B5H9 and this is B5H11, both of them. How this will be named as? Yes, this will be named as pentaborane 9. And this will be named as pentaborane 11. So that there should not be any confusion between the two. Arachnoborane or nidoborane, we always do what? Diborane, triborane on the basis of their number, but at the very same time, we simply write what? The number of hydrogen. This 9 is, telling you what? It is telling you where the number of hydrogen, which is 9. In this case, 11, which is the number of hydrogen here. Is this clear? Okay, guys. So, how to differentiate? With the help of number of hydrogen atom, we differentiate them. So, it is very simple. If it is nido, how to recall that? How many letters are there in nido, guys? N-I-D-O. N-I-D-O. So, this is N and N plus 4. I'm repeating N plus 4. And if it is BnHn plus 4, this has to be 2 more. Repeat, 2 more. So it is BnHn plus 6. Okay? Yaad rahega? Good. I hope you are not going to forget it, isn't it? Good. That's really nice of you all, guys. So let us go ahead. Chemical properties of boron. Let us see, guys. Chemical properties of diborane. So you all, guys, we have already studied banana bond and everything in our previous lecture. If you really want to study them, then the link for them is there in the description box. Okay, so there is a banana bond here like this. This is the bridge hydrogen like this, guys. So this is all, diborane look like. Okay, guys. And yes, this undergo what? Symmetrical cleavage right from here. Symmetrical cleavage. With what? Tertiary amine. How to recall that? Tertiary amine is big amine. Big amine, bade bhaiya, bade chacha. How do they behave? Beta आपस में बराबर बांट लो, kind of. And yes, if it will break from here, we will be calling it as it can break from here. In that case, this is what, guys? Unsymmetrical cleavage. And that will happen either by ammonia, 1 degree amine, or 2 degree amine. Is that clear? And yes, if it is a symmetrical cleavage, it will be breaking like this. If it is an unsymmetrical, here it will be break as BH2 plus and BH4 minus. Hope it is clear, guys. Pakka? Done? Nice. Let us go ahead then. Okay, this all we know that 2 electron, 3 center bond. For that, you just please look my previous video. These are 2 electron, 2 center bond. Okay, 4 such bond and 2 such bonds are there. Okay, let me write down that with again. 2 electron, 3 center bond are 2. 2 electron, 2 center bond are 4. Okay, guys. Now let us go ahead. Let us go ahead, guys. Done. Alum. Let us see what, guys? Alum. Okay. Yes. You know what alums are? You must have heard this time many a times, guys. Let us see. These are basically transparent. फिटकरी बोलते हैं इसे हिंदी में. These are transparent crystalline solids. I'm repeating. This alum are basically transparent crystalline solid, guys. Hope याद रहेगा सबको. Yes, this is transparent. Okay, आगे बढ़े. Now, how do we represent? You know, there is a general formula representation, guys, for alum. General representation for alum is M2SO4 dot M2SO4 whole thrice dot 24H2O. Remember, guys, this is the general representation where this M2 and this is M dash. I'm repeating. This is M and this is, guys, M dash. Simple from the formula that M has to be what? Unipositive. M has to be unipositive and this M dash, guys, it should be tri-positive. I'm repeating. It should be tri-positive. Is this clear? M has to be unipositive and M dash has to be, yes, M dash has to be tri-positive. Clear? Pakka sabko clear hai? Done. So alums are basically transparent, crystalline, solid. General representation of alum is M2SO4 dot M2 dash SO4 whole thrice 20 and 24 H2O. Very good, Alok. Wonderful, beta. Okay, is it clear, guys? मजा आ रहा है बच्चों को पढ़ने में सबको? Nice, very nice of you. Okay, guys, all your eyes on the screen. पढ़ते हैं सबको ही screen पे देखो. Always remember, guys, which element of periodic table are known to show a unipositive and most stable one? Yes, alkali metal, guys. So always remember, we'll be finding alkali metal, but again, Lanka Bhedi. Yes, what which element we are talking about? We are talking about lithium, guys. So Li plus is quite small in size. I'm repeating. Li plus is quite small in size, therefore it cannot meet the structural requirement of the crystal of for formation of alum. Always remember there is a reasoning question asked, why does lithium, I'm repeating, why does lithium not form alum like potassium? The answer to this is, guys, Li plus is very, very small in size, very small in size. I'm repeating, it is very small in size. So it can't meet the, meet the structural requirement for alum. And therefore it does not form alum. I hope it is clear, guys. Paka. Now, so this M plus is univalent, guys, but will never be what? Will never be lithium. This M plus can be, guys, K plus. I'm repeating, it can be K plus, or yes, it can be NH4 plus. Is that clear? Basically, what alum are actually known to us, on the basis of that I'm writing this. They can be either K plus or NH4 plus. Is that clear? If we talk about M dash, which is actually M3 plus here, M3 plus, guys, sorry, that can be, guys, 3 plus, Cr3 plus, it can be Al3 plus, it can be Fe3 plus, like this. Okay, is it clear? Is this clear? आगे बढ़े. Let me clean the entire screen now. Okay. Now, after that, what we are going to see that this alum is going to contain, guys. So, the salt in a ratio like M2SO4, yes, and M2 M dash 2 SO4 whole thrice. This ratio has to be 1 is to 1. They are mixed in a 1 is to 1 ratio, and after that they are fused means what? Melted, and then added up with water. I'm repeating, added up with water. And then finally, as you all know, these salts, they have a tendency to get crystallized. So when they get crystallized, they come out with water of, they crystallize or solidify with water of crystallization, crystallized with water of crystallization, guys. And that is the reason we represent them with what? Yes, with 24H2O. Okay. Now, what are the uses, guys? There are so many uses. They use as a mordant or fabric. Fabric enhancer. There are so many uses. For that, yes, just go for Google. It will Google. Okay. So, guys, let me tell you about, there is one more term you'll be hearing, that is pseudo alum. I'm repeating, pseudo alum. That is false alum. What are pseudo alum, guys? What are pseudo alum? They are also basically, see, here you had taken this positive and tri-positive. In that case, instead of uni positive, we'll be having di-positive cations. For example, FeSO4 dot Al2SO4 whole thrice 24H2O. So this is what, guys? This is di positive. Di positive. Why it is there? Because it is meeting the structural requirement of the alum. But this is not a true alum, because it has to be unipositive, but it is what? Iron is what? Di positive. Similarly, this MnSO4, guys. This is also what? Pseudo-alum. What is it? Pseudo-alum. Is this clear? Okay, done. Now, one more thing, let me tell you the classification, type of alum. You must have heard chrome alum, then a ferric alum, then ammonium alum, potash alum. What are that? Let me tell you. See, if you talk about ferric alum, guys, it is quite understood that ferric means 3 plus. So Fe2SO4 whole thrice has to be there. Okay, this 24H2O has to be there. Then what is here? Take the mono positive one. Yes, that is K2SO4. So this is ferric alum, variety number 1, type number 1. Okay, now if you talk about chrome alum, guys, chrome alum. I'm repeating, if you talk about chrome alum, okay, so instead of this K2SO4, yes, take what? Instead of iron, what? Take chromium. So Cr2SO4 whole thrice dot 24H2. Is that clear? Is that clear? Paka? Good. So this is the second variety, guys. Now the third variety is what? Yes, potash alum. Let us see potash alum. Potash alum means what? Potash is for potassium. Yes. So take K2SO4 and simply put Al2SO4 whole thrice. Tri positive has to come. 24H2O. This is what? Potash alum. And then one more variety is ammonium alum, guys. I'm repeating. Ammonium alum. Very easy to remember. If it is ammonium, you all guys know that ammonium has got a unipositive charge. So ammonium sulfate, isn't it? And let a dot Al2SO4 whole thrice be there. And yes, put 24H2. So simple. It is really so simple to remember, isn't it, guys? फटाफट से लाइक कर दो फिर जल्दी से. Do that faster. Faster लाइक कर दो. है ना? There are the 4 major type of alum, guys. Let us have a quick look. Ferric alum will have ferric sulfate. See, 24H2O, this is the common constitution of alum. So this will be there, guys. Isn't it? Apart from that, add K2SO4. Then just look here, chrome alum, chromium sulfate and 24H2 are there. Add K2SO4. Then ammonium alum. Yes, these are there. Add ammonium sulfate. Then potash alum. This potash for potassium. These are there. Add potassium sulfate. Done. आगे बढ़े. Good. Screenshot. Take a screenshot faster. Done. Let me take a sip of water by then. Now what is there on the screen, guys? Carbon monoxide. Yes, carbon monoxide. You know that when carbon is heated to oxygen in limited supply of oxygen, what happens, guys? It forms carbon monoxide. Is that clear? Or you can also do one thing. You can take CO2 and yes, heat it with carbon. It will also form what? Carbon monoxide, guys. Is this clear? Clear? Or we can also prepare it from formic acid by dehydrating it using conc H2SO4, and that will be giving you what? H2O and CO. Is this clear? Okay, is this clear? Or one more famous preparation has been asked in NEET also, guys. What is it? Oxalic acid. The question was, what happens when oxalic acid is treated with concentrated sulfuric acid? Which all following gases actually form? So all your eyes on the screen. We'll be getting CO as well as CO2. I'm repeating. What happens when oxalic acid is heated in presence of concentrated sulfuric acid? Two type of gases A and B are formed. A is a neutral gas, that is CO. B is an acidic gas, that is what? Acidic gas, that is what? CO2. Simple. सिंपल है, याद रहेगा. Good, guys. Very nice of you. आगे बढ़ें. Let us do this first. Abhi, lot many things are to be done under carbon monoxide, guys. Remember, guys, this is a powerful reducing agent. Powerful reducing agent, It can reduce, like, if we talk about ZNO, it can reduce ZNO to zinc, isn't it? Or if you talk about in blast furnace, this is taken there, it reduces iron this way, isn't it? But yes, it is powerful reducing agent, but it cannot reduce which all element, guys? It cannot reduce alkali metal, alkaline, earth metal, or aluminium. All three AQ, isn't it? It cannot reduce them. Done. आया समझ में? Sure. And yes, like CO2 dissolves in water. CO2 is soluble in water. Does this carbon monoxide soluble in water, guys? Yes, not at all. It is insoluble. I'm repeating. Carbon monoxide is mono. अकेला रहना है भैया मुझे. So ऐसे याद रखो. Mono. Carbon monoxide wants to live mono, alone. It wants to live alone, guys. Okay. Is that clear? Is that clear, all of you guys? Now, one of the very important feature of carbon monoxide is, yes, this used as a ligand. Let me tell you what's that, guys. First of all, carbon, the bonding is somewhat like that. You guys know that carbon has four valence electron. It has four valence electron. Is it? Oxygen has six valence electron, guys, like this. Let me draw two more like this. So there is a proper covalent bond here, guys, but in spite of that, octet of carbon is not completed. So yes, there is a what? Dative bond like this, and you can see there are a lone pair electron on carbon. Is it? Is it? Yes. And yes, you can see there is one sigma and two pi bond also on it. And because of this, guys, due to presence of this lone pair of electron, I'm repeating, due to presence of lone pair of electron on carbon, the CO, that is carbon monoxide, acts as a donor. I'm repeating, this acts as a donor and reacts with, this acts as a donor and reacts with metal, is heating, metal on heating, and forms what, metal on heating to form, guys, metal carbonyls. I'm repeating, it forms metal carbonyls. Okay, and because of this lone pair electron, this also act as a ligand also. It can donate its lone pair, this particular electron to the central metal atom. Okay, guys, is this clear? Now, what this actually, this very property of carbon monoxide is used to purify nickel in Mond's process. Let us see that as well here. What is this Mond's process? You know what happens? Nickel, when it is heated in an atmosphere of carbon monoxide, say around just at room temperature first, and then the temperature is increased to even higher. So even at this temperature, it has a strong tendency to form nickel, yes, nickel tetra carbonyl. When this particular one is heated at 180 degrees centigrade, it is quite stable and it gets broken down into nickel and CO. So you can see this Mond's process is all about purification of nickel, guys. Here this was impure, and so many impurities were also there. Okay, because this was nickel and it was impure as it was with some impurities. When it is heated with carbon monoxide, only the nickel will react with carbon monoxide and will form this nickel tetracarbonyl complex. Okay, leaving all those impurities here only. And yes, on further heating, it gets decomposed into this, and you get what? Pure nickel. And this carbon monoxide can, guys, it can be further used here. I'm sorry, here, this way. This carbon monoxide can be further used here. Okay, I hope you guys are getting it. From here, it can be reused. Is this clear? This process is called as Mond's process. Okay, done. Aaya samajh mein? That's really great of you guys. Let us go ahead with silicons. Yes, guys, this is something very, very most important one. And remember, this is not the particular that usual element silicon. Okay, see this. If you write SiO2, this is silica. If you write Si, this is silicon. And if you write silicones, remember, this is something different, guys. They are basically, they are extremely, actually, basically, they are, kind of a compound which are very highly thermally stable, you know electrically insulator. And yes, we can use them in bakeware, or you must be like silica container, silica spoon, silica bakeware. So many things are there in the market now. They are microwave safe. Yes, they're very much microwave safe. They're very hygienic. They're very easy to clean. So basically what this are, made up of, let me tell you, these are basically synthetic. I'm repeating, these are basically synthetic organosilicon compound. Synthetic organosilicon compound which is having, guys, repeated R2SiO. This R2, where this R is for alkyl, and SiO units. They have got repeated SiO units, guys. I'm repeating. They have repeated SiO units, and all these are held by what, what type of linkage? Very simple. जहाँ silica है वहाँ ये होगा. This linkage will be there. This is the linkage. Is that clear? Is this clear, guys? Done? Wait. So we don't have any space, so we'll need to clean this. Is this clear? पक्का. चलो आगे बढ़े. Very nice of you all, guys. So happy to see you that you all are really, really good. You all are studying it. So guys, all your eyes on the screen now. And yes, if you have not liked the video, please like it fastest. फटाफट से like कर दो and share it to all your friends. Share it, just share it to all your friends. Okay? And if you're new to the channel, don't forget to subscribe it. And yes, at the same time, press the bell icon in order to have further notification. Do that faster, guys. And all your eyes on the screen. Yes. देखो फटाफट से let's look at the screen now. So guys, compounds, these silicones, they have got general formula, like they do have these are polymeric chain. Every polymer has got a certain repeating unit or a general formula. So they do have, what is that? R2SiO. This is the repeating unit being repeated. So we will collectively represent it this way. Is that clear? Where R is, guys, nothing but what, alkyl group. R is alkyl group. Let us see what happens or how actually they are formed. First of all, what, we take alkyl halide. Let me repeat. Yes. What happened here? Yes. Any doubt? Please note it down in the chat box. If you have any doubt related to the topic, or you really you want to know something, then please chat in the or drop message in the chat box. Okay, yes, all your eyes on the screen, guys. So what happened? This R seal is treated with silicon. in presence of copper at a very high temperature, somewhat around 300, are we going to get? We are going to get right from R3SiCl, will be getting R2SiCl2, will be getting R, yes, SiCl3. Okay, all these three compounds, variety of compound will be getting, guys. And yes, these are actually acting as a monomeric unit, okay, to form this particular giant molecule or silicone. Let us see how. Can you see this is R3SiCl? How to remember this? How to remember this? See, Si is tetravalent. Okay. First of all, do one thing. Take SiCl4 and just keep on replacing one by one the Cl by what? R group. Here also R group can be formed, but that is not, we are not going to use it much, isn't it? And what do we call this 1, 2, 3, guys? They can be, remember, this can be, R can either be alkyl or it can be aryl group. Okay, guys, on the basis of, requirement, they can be alkyl or they can be aryl. I'm repeating, they can be alkyl or, guys, they can be aryl. Is that clear? क्लियर है पक्का समझ में आ रही है now what is done this also can be prepared this guys this can also be prepared by taking this is one preparation they can also be prepared by taking RMgCl. You very guys very well know what is this called as RMgCl. Okay, and just take SiCl4 and keep replacing, as I just now told you, keep replacing the Cl of SiCl4 with that of R. So you'll be getting RSiCl3 or R2SiCl2 or R3SiCl. Okay, guys. So if here you'll be doing this, you can do this, all these product. So these are actually we are supposed to take. Okay, we'll take them and we will, yes, we will hydrolyze them. What we will be doing? We'll be hydrolyzing them. Okay, first take a click, guys. Fatafat say, take a click faster. Done. Now let me clean this first of all again. Okay. Now let us see the line diagram. Repeating, line diagram, so that it can become more clear to you, of formation of silicon, guys. Line diagram of formation of silicon. So what is done, guys? We have taken our MgCl just now, reacted with SiCl4. We saw that our SiCl3 is forming. Okay. Now what is done? First of all, this RSiCl3 is further, what it is done? It is hydrolyzed. I'm repeating. This is undergo hydrolysis. So after hydrolysis, what will happen, guys? After hydrolysis, what will happen? You'll be having R, Si, and as many Cl, all of them are going to hydrolyze like this. Is that clear? If two are there, so there will be two. Similarly, if you have R2SiCl2, it will be R2SiOH whole twice this way. If it is R3SiCl, this will get hydrolyzed at R3SiOH. Is this clear, guys? Pakka. So we call this as what, alkyl or aryl substituted chlorosilane. These are what? Alkyl or aryl substituted chlorosilanes. Okay, is this okay? Fine. समझ में आ रहा है यहाँ तक? Done. All you guys are understanding it. Now let us see how the polymer linkage is forming. Come on, take a screenshot. Okay. Now what happened, guys? These units, gets aligned up like this, okay, are in such a way that their OH group is facing each other. For example, if we talk about R2OH whole twice, this hydrolyzed product I'm talking about, they get aligned in such a way as I'm going to draw on the screen. Okay, like this. Now, this will undergo dehydration like this. And yes, it will be forming a linkage like this one, guys. SiO then R, here also R and OH. Is this clear? This type of linkage will be forming. Is this clear? Okay. Now this will further undergo bonding like this. And this is how, guys, a long chain will be formed by having this unit keep on repeating. Is it? You can see a long chain, okay, will be formed. And on termination, what will be happening? A compound which is having R3OH will be combining. Suppose we talk about termination. This is R, this is R, this is R. It will be undergoing this way. As there is no further R, so there is no further propagation of the polymeric chain. So whenever you want to terminate a particular chain, bring such, you know, bring such hydroxy product in which there should not be any OH bond left after dehydration. And this is how the silicone structure will be formed. Is this clear, Pakka? Is it clear properly? If it is clear, sure you all guys it is clear. Nice of you. Okay, now all your eyes on the screen. How does this whole structure look like? Let me tell you. So, suppose this is Si, R here, and there will be SiO, Si linkage, O, there also O. Okay, guys, here R will be there. Again, this type of linkage, R will be there. Again, this type of linkage. Is this clear? This will be keep on repeating like this. Okay, is this clear, guys? Now this is how the entire structure look like. Okay, this is R. So this is, guys, silicones. I'm repeating. This, wait a second. This is silicones. Clear? Hai? Is it clear? They can withstand very high temperature. They're extremely elastic. They do not undergo any kind of chemical reaction and therefore they are microwave safe. So these are the properties of silicones. Remember, silica is SiO2, silicon is simply Si, and silicones is this. Okay, done. आगे बढ़े. Let's go ahead, guys, now. And yes, study the last topic of this one, and that is silicates. Okay, let us study silicates, guys. The last topic under it. Now, silicates. What are silicates, guys? What are silicates? Silicates basically will constitute of silicon and oxygen, isn't it? Yeah. So let us see silicon and oxygen. The electronegativity value of oxygen is 3.5. It is 3.5, and that of silicon, just now in the beginning of the class we saw it is 1.8. After carbon, all of them have same electronegativity. So the electronegativity value of silicon is 1.8 and that of oxygen is 3.5. What is the difference, guys? Come on, tell me. Yes, the difference is somewhat, difference in electronegativity is somewhat 1.7. And you guys know that when difference in electronegativity is between 0 to 1.2, this is non-polar covalent. When this difference in electronegativity is between 1 to 1.7, It is polar covalent. And when the difference in electronegativity is more than 1.7, it has got ionic. So this you can say the bond because of this is very, very stronger. And actually this is the reason that these silicates are very, very hard compound. I'm repeating, this is the reason that these silicates are very, very hard compound, guys. Okay, is this clear? Pakka hai? Pakka clear hai? Good. Now let us see the classification of how many type of silicate. First of all, silicic acid is H4SiO4, guys. So from this the silicate unit has came into picture. SiO4 4 minus, the simplest silicate unit which looks like 4 oxygen being surrounded this way. Okay. Uh, Now, so this is the simple one silicate unit, and actually the different types are on the basis of this silicate unit is joined to how many silicate unit further. I'm repeating, how this silicate unit is joined further. On that basis, it will be decided whether one dimensional, two dimensional, simple or double chain like. Okay. Now let us see them again in a proper classification way. So suppose if we talk about one dimensional 1D silicate, guys. Okay, under that the very simple one is simply orthosilicate. That is what SiO4 entire has got a charge. This. And the second one under that only 1D. The second one is yes pyrosilicate. Pyro acid means when ortho acid, when two of the ortho acid, if one water molecule is removed, it results formation of pyroacid. Remember, I'm repeating, it results the formation of a pyroacid. Okay, guys. So this is pyrosilicate, guys, and pyrosilicate look like Si2. I'm repeating, it looks like Si2O7. And yes, what will be the charge on it? That will be 6 minus. Let us explore why the charge is X minus. Suppose this is O minus and O minus here. Here also O minus and O minus, guys. And now this is O minus and this one is O minus. In case it is a pyrosilicate, you know what will happen? One oxygen has to go away from here, isn't it? That is the reason I drew it again and then just erase it. Just wanted to show that yes, if the linkage is like this, 2 minus charge is going to remove, is it? 2 minus charge will be removed. So when two silicates unit are joined together, the net charge on them will be due to these 3 oxygen only. This particular one will not have any charge. I hope it is clear. Now coming to that, 1D is cyclic formation, guys. I'm repeating, cyclic formation. In this cyclic, what happens? In this cyclic, what happens, guys? These are connected like this. Si at the center, okay. Si at the center, here also Si at the center, and each two of them are connected to, each silicate unit is connected by one oxygen like this, here also, okay, guys. And the other oxygen which is here having a negative charge, same here, same here. And yes, just top to the silicon there is one more oxygen with negative charge, here also negative charge, here also negative charge. And this silica is connected to all this way, guys. Okay, now how will you represent it? Simple SiO3, Si and O3 unit is getting repeated several times. Therefore, it will be represented this way. And can you tell me how many charges it should have? Let us calculate now. There are three silica units you can see very well joined together. But charges are 1, 2 here, 1, 2 here, and 1, 2 here. So net charge present on them is how much, guys? In this total unit? Yes, how much it is? They suppose this is 2 silica units. So, I mean 3 silica unit. I'm repeating. This is 3 silica unit. So, on this, the charge is 6 minus. So we can write down a general formula as SiO3N here, and just twice of that, that is 2N minus. Is it clear? So this is how 1D orthosilicate, pyrosilicate or cyclic silicate is done. Or we remember the formula. This is how. आया समझ में? I remember this is very remember guys, this is very difficult to recall it. So all your eyes on the screen. So this is how you just recall their charges and their formula, because it only comes that which of the following is representing this, or cyclic silicate or chain silicate kind of. I hope it is clear guys. पक्का समझ में आ रहा है सबको? Sure. So this is all 1 degree. Is this clear guys? This is all 1 degree silicate. Done. Now 1 uh, degree silicate also has chain silicate. This is cyclic. It also has guys chain silicate. I'm repeating, this also has chain silicate, and in chain guys further divided as simple chain. I'm repeating, simple chain, and the other one is double chain. The simple chain are simply represented this way. That means you can see they are just like this, but only one unit is shifted from here to this side. So whether you talk about cyclic or simple, remember, cyclic or simple chain guys, the formula remains same. Cyclic and simple chain, I'm repeating, they have got same formula. Same formula. Is this clear? Is it clear, guys? Okay. Now double chain. Let us look that. See, one layer is this way. The other layer will be like this. Suppose this is the one layer. The other layer will be this way. That is called as, yes, this way. It is called as double chain. So let us draw the chain like this here. Okay. The other one will be, you simply have to draw, bring one chain like this. So the other will be just, you have to simply, suppose ऐसा कर लो, just same way. That is the reason these are attached like this. Okay, is this clear? Is this clear? Doesn't it look like a star this way? The two chains are joined together, guys. Continuation. Is it okay? This is called as double chain. Can you see? One chain is right from this side, the other one from this side. Therefore, this is called as double chain. Now, the most important one, how to recall the formula of double chain. Let me tell you that. So, what is done here? First of all, what is done? Let me tell you. Here, what we write, we take as Si over here. There is a minus charge over there. Now there won't be any charge on this oxygen. Then again silicon over which a minus charge. And again there is no charge on this guys. Then again there will be a silicon over which minus. There won't be any charge over here. Then again silicon over which minus charge. Okay. And this is how they all are connected here. Is this clear? Is this clear? Now there will be a minus charge here. Similarly, here one oxygen with a minus charge. Okay. So guys, just look at this unit, which is actually repeatedly. Just look at this one from here to here. Okay. How much charge is there? How many SI? 1, 2, 3, 4. Write down SI 4. How many oxygen are attached to that? How many oxygen? Si4. 1 top to that. 1, 2, 3, 4, 5, 6, 7, 8. Just top to that. Isn't it? 9, 10, 11. So there will be 11 oxygen. Okay. So just take it as N unit. Now how many charges are there? How many charges? See, there also, this also you have to take now. This, we are repeating this total as one unit, guys. But as they are further attached, there is no charge over them. So total charge on them is going to be only 6n minus. Is this clear? Here n and 6n minus. So as many unit, that many charges. Is that clear? Pakka. Okay, is that clear? Done. And if we talk about, yes, let us talk about, guys, 2D and 3D. So if we talk about 2D, what happens? Yes, each is connected to, each silicate is shared to other one by 3 oxygen, like this. So all these 3 are connected, so there won't be any charge on this. Done. Suppose there are 2 unit, okay. So 2 unit will have Si2, Si2, how many oxygen? 2 units should have Si2O5. And yes, there will be only charge on them due to this, because they are connected to with these oxygen. All 4 oxygen will be on. Easy to remember, Sa10. If you are new to the channel, don't forget to subscribe it. Press the bell icon also. Okay. And yes, don't forget to share to all your friends. So it's time to say bye-bye. Bye for now, beta.